In this video, we're just going to summarize the different types of factoring that we've seen throughout the unit. This goes with lesson 4.6 since it's a good summary of all the different techniques that we've seen so far. Specifically, the first page in the first video of 4.6, that's what you should be using this flow chart with. So again, whenever you're given a polynomial to factor, look for a common factor first. Look for that greatest common factor. And if there is none, fine, move on and do the other techniques that I'm going to show you, but greatest common factor first, because that will often open up to other techniques that you can use later. So our next little trick is, are there two terms? If there are two terms, so for example, if we have, let's say, x squared minus 4, then what you're dealing with is a difference of squares. So if there are two terms, if in those two terms you have, in between those two terms there's a minus sign, and you have perfect squares for your first and last terms, so let's call them perfect squares. If yes, then we have a difference of squares. And so if you have a difference of squares, for example, if we were doing this, you would simply know that that's equal to your two brackets, square root of the first term, which in this case would be x, square root of the next term, which would, square root of the first term would be x, sorry. Square root of the next term is 2. And then we put our plus and our minus. If you had a positive sign, so if positive sign in between them, so for example, x squared plus 4, and there were only two terms in positive sign, then you can't factor. That just stays as is. You can try as hard as you want, but right now you can't factor. But the main idea here is that we took out a greatest common factor first, if that was possible. Then if that wasn't possible, or if you opened it up to this and you had two terms, and there was a minus sign in between, they were perfect squares, then you could simply use a difference of squares method to go ahead and factor that for yourself. In other circumstances, you might have three terms. So you might have a polynomial that looks something like this. Here's an example of three terms. So we have x squared minus 7x minus 18, but they're not always that simple. Sometimes you might have three terms where you have this one here, this one specifically, it's a simple trinomial. There's no perfect squares. Your a is equal to 1. A is equal to 1. And in that case, what you're going to do is you're simply going to find your product. That's going to be a times c, which is just the last one. So in reality, 1 times c, which is just c. And a sum, which is equal to b. So in our scenario up here, we want to find two numbers that when you multiply them, they give you c, and when you add them together, they give you b. So it looks like for our product, we could have minus 9 times 2, and minus 9 plus 2 for our sum. That would work out. So we would get x minus 9 and x plus 2. So when your a is equal to 1, you're just looking for your product that's equal to c, and your sum that's equal to b, two numbers, and then you can put them into those two brackets as is. And that's a simple trinomial. Sometimes we don't have simple trinomials. Sometimes we have a case where a is not equal to 1. It's something different from 1. This means not equal, where you have an equal sign, you put a line through it. So in this case, we're looking for two numbers where the product is equal to a times c, and this time it won't just be equal to c because a is something other than 1. And then when you add them together, their sum is equal to b. So an example of that would be if we had, let's say, 2x squared plus 7x plus 3. So our product would have to be, in this case, 2 times 3, which is 6. And our sum would have to be 7. So two numbers, when you multiply them, they give you 6. When you add them together, they give you 7. And so that seems like 6 times 1, 6 plus 1. So 6 and 1 are the numbers. But the problem is that we have to use our decomposition. So it's a bit of a different technique this time. So we're going to decompose the middle term into the two numbers that we found. So we can do 2x squared plus 6x plus x plus 3. We've decomposed the 7x into the two numbers. This is still 7x, 6x plus x, but we've decomposed it. And now we've made these groups that we can use to try to factor things out if possible. So let's factor something out of this 2x squared plus 6x. It looks like we can factor out a 2x. Let's erase that and do that properly. We can factor out a 2x from those terms there. So 2x, divide each term by 2x there. So that's 2x squared divided by 2x. That's x. 6x divided by 2x. That's plus 3. Plus 3. And then over here we have our plus x plus 3. Now you'll see why I'm putting this in the bracket in a minute. In reality, what you have here is actually plus 1 times x plus 3. And so what that means is we have x plus 3 as a common factor there. So one of our brackets will have x plus 3. And the other bracket will have what's left over, 2x plus 1. So sometimes the ones that appear simple can be a little complex, especially if you haven't had a lot of experience with it. So that's why I chose this one as an example here, as a different way to view it. But it's still using decomposition. Sometimes you might have 3 terms, and you'll get lucky and you'll have a perfect square trinomial. So remember that your first and last terms, first and third terms, needs to be perfect. They need to be perfect squares, so PSQs. And your middle term needs to be either 2AB or negative 2AB, depending on the sign that you have in your trinomial. So let's say, for example, I had 4x squared plus 4x plus 1. You might have said this is a trinomial with a is not equal to 1, so you have to use decomposition. You could have tried that, but it's always nice to check to see if you have a perfect square trinomial first. The first term is a perfect square. If you do the square root, you get 2x. Second term, the last term is also a perfect square. If you do the square root, you get 1. Let's see if our middle term is 2ab. So it's 2 multiplied by the square root of the first term, which is times 2, multiplied by the square root of the last term, which is times 1, and that would be equal to 4. So yeah, so that meets all the criteria of a perfect square trinomial. So what that means is if you have that scenario, you can simply open up your brackets, put a square on top, take the square root of the first term here, which is 2x, take the square root of the last term here, which is just 1, and then put the proper sign based on the sign here, which is plus. So again, I've went over this quickly because you've seen this in the previous lesson, but that's just a nice summary of if you do have 3 terms, what are your possibilities? Simple is fine, great, but try to look for that perfect square trinomial situation, especially if your a is not equal to 1, so it prevents you from having to do decomposition. You can use a variety of different techniques, it's up to you, but try to choose the one where you have a little bit less work to do to be more efficient. And then, like I said, sometimes you might have scenarios where you have more than 3 terms. You have 4 terms. So for example, we have 6x squared plus 9x plus 2x plus 3. And as usual, you would need to look to see if there's a greatest common factor you can take out. But if there isn't, what you want to do is you want to try grouping. Try grouping them together in ways where you can take things out of different groups, and then that might allow you to factor further later. So if I take a look at this example here, anything that's common within groups, I mean, it looks like I could take out a 3 from here, perhaps. That could maybe work, but then if I look here, there's not much that's common there. So I'm going to try to rewrite this in a way where I do have some commonalities. Maybe I can do 6x squared plus 2x plus 9x plus 3. And so I've created groups where the pairs have some commonalities now. So for example, here, I can take out a 2x. I can do, that's equal to 2x. If I do 6x squared divided by 2x, that's 3x. And then 2x divided by 2x is plus 1. And then from here I can take out a 3. Plus 3. And then if I divide by 3, so that's 3x over here, plus 1. And so you've created a situation where you have a common factor that you can take out, the 3x plus 1, from the brackets there. So I can open up the bracket 3x plus 1, and what's left over is a 2x and the 3 there, so 2x plus 3. And so what seemed impossible to factor at first became much easier once I did this grouping technique when there were 4 terms available. So have this chart with you when you're doing your homework. It's a great way to make sure you're thinking of all the different possibilities. And what I would recommend that you do as well is for any one of these examples we did here, you can verify. You can double check and you can verify to see that you were on the right track by just expanding them. So you can expand this, you can expand this, expand this, expand any one of these to see if you get back to the example, the standard form that we had before. So overall, we've seen standard form and factored form. We've seen how to go from standard to factored forms, and you also know how to go from factored forms to standard forms by expanding.